So now we're looking at y equals -3 cosecant of 8x. First thing I'm going to do is think about the reciprocal function of cosecant, which I know, of course, is sine. These are things that I'm learning and getting more familiar with. Only thing I'm going to change about it is that cosecant is going to be sine. I'm going to use the sine graph as my guide. I'm not going to actually graph it. And in this video, I'm going to just do a quick review of how I might graph that -3 sine of 8x function. If you feel like you know how to do that, you can go ahead and skip this video because I'll start the next one recapping the finer points of what happens with all this great stuff right here. Same thing as with cosine. We know that sine, whatever sine's doing at 0, it does that full rotation around the unit circle, and once it hits 2 pi, it just starts to repeat itself over and over again. The standard sine does. So I just need to think to myself, when am I taking, like, what value of x makes me take the sine of 0, and what value of x makes me take the sine of 2 pi? I'll be taking the sine of 0 whenever this is 0, so whenever 8x equals 0. I'll be taking the sine of 2 pi whenever what's inside of here equals 2 pi, so whenever 8x equals 2 pi. So some simple algebra would tell us that this is going to equal x equals 0. Dividing both sides by 8 means x equals pi over 4. Cool. Now I need to take this one full period where it starts to repeat itself and break that into 4 equal pieces, one for each quadrant of the unit circle. 0's here. It's great. I don't ever draw things to scale. I really should. If you guys want to learn more about what's happening, you should too. But I'm trying to work with this digital pen. I don't want to make it too difficult. So the halfway point between pi over 4 and 0 is what I would get. Half of pi over 4, if I was to multiply it by a half, I would end up doubling that denominator. So pi over 8. Half of this to get a quadrant would be to double the denominator again. Pi over 16. I'm going to now think about these as all being over 16. I write it down so you can see what I'm thinking, but this happens in my head. Okay? This is pi over 16. I'm thinking this is 2 pi over 16. This is probably 3 pi over 16. And I can verify that by knowing that this would be, to get this to be 16 times by 4 pi over 16. So it's pretty clear to me that this fourth quadrantial piece is going to be 3 pi over 16. And of course I'm going to have those same exact values on this side because there was no phase shift happening. When there's a phase shift, it's a little more complicated, but to be honest with you guys, I'm not going to ask you about any complicated phase shifts. I'm not going to. There's no reason to. All right, so if I'm doing sine now, if I'm doing this function, I do note that the amplitude is 3. Like this function would normally max out at 1. But I'll be multiplying those 1s by 3. So this will max out at 3 and -3. And once again, keeping in form, I'm going to go ahead and walk, what a mess, Mr. Depsic. That will not stand. Those of you who make your Cami assignments so nice and pretty, I really fully respect you. I don't know how you guys do it. Oh my gosh, now why is that happening? Come on, stop it. And then 5 over 4. Okay. 1, 2, 3. Oh my gosh, I'm so sorry. There's a full minute of me just dinking around with my pen. So we know that sine normally starts at 0. And it would normally go up, but this is negative, so it'll be down here, back to the 0 line, up here, back down here, and then we'll continue that pattern. So up, down, down, back up. These are going to be my key points, where I'm going to start working with the cosecant graph. So the next video will kick off with these blue points and how to use these blue points to figure out what the heck's going on with that blue graph.